we're looking at the rational function y equals 3 minus 4x over 3x plus 16. And we're going to find the vertical asymptote. Let's find that first. And then we're also going to find the horizontal asymptote. And then we're going to see about graphing the function. Okay? So finding the vertical asymptote. And we want to look, when we're looking for a vertical asymptote, we're going to want to look at the denominator. So that's what we're going to look at. And what we do with it is we set it equal to 0 and see what gives us 0. So we solve for x and divide by 3, and I get x equals negative 16 over 3. So this would be my vertical asymptote for this function, so that's what that tells me. The next thing we're going to look for is the horizontal. Okay, so we found the vertical, and now we want to look for the horizontal asymptote, if it has one. And this one does. You always look at your exponents of your variables. You want to look at the highest exponent, and here we have x to the first, 3x to the first, and negative 4x to the first. So you notice on the top and bottom, the highest exponents are the same. The top and the bottom are the same. So actually that makes it a little easier for us to find a horizontal asymptote. Now there's several ways you can do this, and I'm going to kind of share just a little bit of a shortcut. If you notice that the denominator and the numerator, denominator, numerator, let me get my one straight. Here's my denominator, here's my numerator. If the highest exponents are the same, which these are, we only have actually one variable, so we're only looking at to the first power. If they're the same, I like seeing that because that tells me what I need to look at as far as our asymptote. I just want to look at those two terms. I'm not worried about the 3 or the 16 when it comes to the horizontal asymptote. And so I just want to look at the negative 4x over 3x, because what we're looking at is what does my y value go to as these x values get very large. Okay, so as these x values get very large, our y value goes to negative 4/3. That's what we're looking at, because since x over x, since they're the same, those are going to increase at the same rate. So what's my horizontal asymptote? Well, y is going to equal negative 4/3. So that is my horizontal asymptote. Now we want to look at, okay, x or y intercept. So let's go to the next page, and let's find our y-intercept. And remember, what's your y-intercept? Your x is 0. So I'm going to plug 0 in for my x and see what I get for my y. So when I do that, and this is actually pretty nice because that cancels, that's 0, and I ended up getting 3 over 16. So that would be my y-intercept is 0, 3/16. And then our x-intercept is where you let your y equal 0. And we really, when we're dealing with a rational expression, I just need to look at that numerator. Okay, so I let my y equal 0 and see what happens when my y equals 0. What's my x? And it looks like x is going to equal 3/4. So that's going to be my x-intercept. So remember, that's where my y equals 0 and my x-intercept. So there's my x-intercept And there's my y-intercept. And now we have everything. I think we have enough to graph our function. Okay, so let's graph our function. And here I have my x-intercept and my y-intercept. So we have 3/4 0 for my x-intercept. So we're going to say about there. And then my y-intercept is 0 3/16, which you may want to say, okay, well, what exactly or about how much is 3 divided by 16? And that's about 0.2. 2/10. So just not very much. So we're going to do just say about there. What else do we know? Well, we know we have a vertical asymptote, right? And our vertical asymptote was -16/3. So again, you might want to think about, well, what is -16/3? That's a -5 1/3. So let's see, let's get our vertical asymptote there. 1, 2, 3, 4, 5, and 1/3. So, and that's if everything is 1, if we're counting each unit as 1. And then our horizontal asymptote is -4 thirds. So that's about, what, -1 1/3? We're looking at it being something like this. So yeah. And so we know our graph for vertical asymptote is going to be going up and then coming down. Okay. And then the other side, you always could plug a few points in here. Just to get an idea of what we might have. So we could look at possibly -6 to see what that would give us. So you could always find you some points and get an idea of what the graph is doing on the other side. But one thing we do know, it's going to be getting close to these asymptotes. So it'd be something similar to that graph. So anyway, it's good to get an idea of what your graph looks like. You could always graph it on a calculator, which helps a lot. A lot on these graphs, a lot of times you just get some rough sketches as far as what they look like. That might be a little more accurate as far as, let me erase this one here, as far as what your function looks like. Okay. If you have any questions, just let me know.